And use this to review for your little mini quiz. So we're solving for x, and these first two just tells you it's a side length. And note that there are two right triangles. The 50 on this first one, the 50 is on the left triangle. So not something that we can just like copy and paste into the right-sided triangle. So how do we work over there to get x? Any thoughts? Like, first of all, don't assume it's a isosceles, right? We can't do that.
I don't know if it's right, but I did the cosine of 22 and I found like the up and down one, and I used that as y.
Okay, so you said y over 50?
Yeah.
Okay. Good degree? Is that something that we can do? Yeah, that's the best strategy. So 50 cosine 22, what'd you get for that?
46.
0.3. Okay. Yeah, and so that gives us something that we can use, and with less work, we can use it to find x. What if you had found this bottom little length on the left kind of half side of the bottom of the triangle? Would that help? I'll just label it. Like if we called this z, would finding z help with finding x? Yeah, I guess it could, because then you could do Pythagorean theorem to find y, but that's extra work. And why would you, right? All right, how do we get x from knowing that y is 46.3? Yep. So we just do it again. Cosine of 41 is 46.3 over x. So the ratio flips now because x is the hypotenuse. Okay. Multiply by x over 1. Then divide by cosine of 41. And what did you do that?
No,
Okay. So, whoops, this thing always resets.
I got 60.3.
Yeah, by the time I get it done, we're all going to be old. Oh, wait, you already are, Mr. Jackson. All right. So 61.3. So a couple of repeated uses of cosine in that case. I was just trying to think if there's another way. I think that's for where we are in the course, that's the only way to do that one. All right, 34, probably kind of similar. Only this time we're finding x on the bottom. So let's do a similar process. Cosine 25 equals y over 48. And that gives us 43.5 for that altitude. All right, this time, what do we set up to get x? What do we set up to get x? Yep. So this time, x is opposite of the known angle. So tangent of 59 equals x over 43.5. And then multiply by 43.5. And we'll get x equals 43.5 tangent of 59. By the way, just a reminder, when you're using a calculator like this, if you just go grab that result, like go highlight it and hit enter, now you're working a little bit more accurate because we didn't round just to the 0.5. Not that that's a huge deal, but it's kind of nice. So 72.4. Okay, how'd those go? Can you do them on the quiz or something like it? Down here, find the angle. So same idea in terms of setup, but a little bit different solving. So what relates our angle and those two side lengths? Yeah, so remember we can label. This is opposite and then hypotenuse. So OH, which one is OH? That's sine, so sine of theta equals 51 over 55. Should this be like a bigger angle or a smaller angle, do you think? And when I say that, I mean, we know we're going from 0 to 90, right? Like in that range. But is it going to be closer to 90 or closer to 0?
In the other angle or compared to?
No, just when we get our result, should we, it's nice to have some anticipation of what to expect, right? Because if you get like 5 and you expected 80, then you'll be like, something happened. So I'm asking, do we expect it to be closer to 90 or closer to 0? Yeah, and if we look at our ratio, it's almost 1. And remember, if we're thinking unit circle, the sign represents the y coordinate. So it has to be pretty close to 1, like we're almost full length, if you want to call it that. So we're thinking that angle is going to be pretty steep. Now, I know we have the picture, but don't rely on pictures. Rely on the numbers are more accurate than pictures. Pictures are usually not drawn to scale. How do we undo this sign so that we can just have theta? Okay. It's called inverse or arc. Yep. And then do it to both sides so that we stay balanced. And basically what it's telling the calculator is that we have this side length ratio, the ratio of an opposite to a hypotenuse ratio. It says, like, ignore the left side. That right side says, go look up what angle is that ratio for the sine. That's what it's doing. So shift or inverse sine of 51 over 54. Is it 54 or 55? So 70 degrees. So closer to 90, we expected it to be. So solving for angles, how do you feel about that? Wait, what? Oh, why did I do that? Thanks. Anyway, any issues with finding angles? Okay. So just a quick reminder to use this, please. So Katoa, to help you set up or to calculate the correct ratio. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Just write it. You could write it once and reference it over and over again. Let's do a quick check on the homework. And, before we do that, we're going to do the number 11, the Bill Owen architect problem. These are not going to be on your little quiz, but they will be on your test, so might as well make sure we're doing okay with them. So we're designing a new parking garage, and the floors are 10 feet apart. This is kind of a weird description. Okay, so I think you guys are caught up now. Make sure you're listening. 10 feet apart vertically is what this is saying, okay? And then it says exit ramps between each pair of floors are to be 75 feet long. So what is the measurement of the angle of elevation of each ramp? So if we just kind of think of that as two different floors maybe in our garage, and call it something, floor 1 and floor 2. We know that they are 10 feet vertically from each other. And then if we're driving from one to the other, we're driving up some ramp. Have you guys ever been in a parking garage before? Okay. They don't, I mean, obviously my picture's way simplified, but the concept is there. It says the ramp is 75 feet long. And I take that to mean the surface you're driving on, not like the horizontal distance. So I'm putting it on the actual like road surface. And then it says, what's the measurement of angle of elevation? So that would be there. And which ratio are we looking for in this case? And remember, a good strategy is to go label. So 10 is across from theta, so it's opposite. And of course, 75 is our hypotenuse. Which one is that? So sine of theta is 10 over 75. And again, this is where we do inverse. So theta equals inverse. Actually, this time I'm going to write it with the arc sine, not tangent. Arc sine of 10 over 75. 10 over 75, do we expect this to be a big angle or a smaller angle? Since we drew the picture, we really can't rely on that. So is it closer to 0 or closer to 90? 7.7 if we round. No, that's not true. Yeah, it is. Oh, it just reduced it. Never mind. This calculator kind of bothers me how it does that. So 7.7 degrees, that's a small angle, but when you're driving, it's interesting that small angles feel steep sometimes. Okay, any others that you'd like to do? 12, okay. So two buildings are 60 feet apart. A person on top of the shorter building finds the angle of elevation. So that's 60. To the top, or to the of the roof of the taller building to be 20. Let's see if I can do that better. Okay, remember angle of elevation is with the horizontal, looking up, so 20 degrees. And then the angle of depression of its base to be 35 degrees. So now we're looking down at the bottom. And let me move the 60 over here, 60 feet. Now we're looking down at the bottom from the horizontal, so that is 35 degrees. How tall is the taller building to the nearest foot? So essentially we're going to find two lengths, maybe call it x and y, and then h is just the sum of them, x plus y. So we see two right triangles. Why are the triangles, the blue triangles, right triangles? Okay. Yeah, well, not all of them, but we'll assume that just the left building, in my picture, the taller building matters. But if we assume that that wall is perpendicular or straight up and down, and you're right, most of them are. So, and then of course we're looking, part of this is that we're going to be looking straight across at it, not looking at an angle to form our triangle. So horizontal distance is 60 feet. Okay, so we really have two triangles that we're working with. And which ratio is this one? Yep, that's tangent of 20 equals x over 60. And then the other triangle, same ratio. So tangent of 35 equals y over 60. Does that help? Okay, any others? Any other questions? Okay, I'll just show you the answers then. So first one, the second guy, the Ryan's angle of elevation should be 58.4 degrees, 58.4. Number 8, the two buildings are 84 feet apart. Number 9, there we go. Number 9 is 2.2 miles or 11,379 feet. So if you did yours in feet, it would be 11,379. Okay, number 10, 11.8 kilometers. The towns are that far apart. Number 11, we just did that one. So 7.7. And then number 12, the answer to that one is 64 feet tall. So any questions on those? Nope, we're all good. What's the... Okay. You were 3,000 feet off?
No, it was like 60.
All right, number 1 was 12/20ths. So cosine adjacent over hypotenuse. For z. Are we good? Okay. All right, this table one. So sine of A, opposite over hypotenuse. So opposite of A is 9 over 3 root 13, but we can't leave 3 root 13 in the denominator. Well, the 3 is okay, but not the root 13. So rationalize by putting it up. Remember that, what I'm talking about? She asked, does it count if we put the decimal? It didn't specify, so if your decimal is the same, then yeah. Well, you could have asked. Cosine of A. Anyway, so adjacent over hypotenuse, 6 over 3 root 13, and then tangent is just 9 over 6. All right, number 3. So sine of 30 is a half, cosine of 60, yeah.
You forgot to rationalize for number
Well, it didn't say to do that. I think I'll give you credit. Number 3. Number 1, guys, you had your calculator. You could just punch these in, like, right? But also, remember that this is that complementary trig ratios concept that we kind of focused on 2 days ago. So if sine of 30 is a half, then cosine of 60 is also a half. So 30 plus 60 is 90. So once you found one of them, you could find the other without having to check your calculator. Okay, number 4, we needed 2 lengths. So this was a little bit more work. EF, you could use either of the 2 angles, 52 or 38. Let's say you use 38, you would just do sine of 38 equals x over 18, and then solve. From there, you could use Pythagorean theorem with those 2 to get the third, or you could do cosine of 38 over 8 is y over 18. Anyway, then add those up. Number 5, finding the angle of J is tangent 15.1 over 9.4. So how'd you do? Here, just to give me an idea, like give me a fist of 5. 5 is 100%. You can do halves, like 4.5. What was yours? Okay. All right. I'll do a quick grade on those, and you can look at them next week. But all right, grab a sheet of paper and tell me what you know about that, please.
Are we like 20 minutes?
This what?
Like this? Or is it
No,
just-
no. Yeah, this is just thinking. We have like 10 minutes, so.
What time it's like, so it goes, after this class, then we go to 6th and then assembly? No, it's assembly.
Assembly is next, and then 6 before lunch.
That's so weird. I don't know. Thank you.
Yep. Go ahead and solve for AB, please. Oh, can you let her in? Shoot. I was thinking bathroom area. Okay. Sorry. You could have come in a couple minutes ago. Thanks for waiting. We're trying to solve for AB. Huh? What? You're Robin. You can't be. You can tackle anything. People are saying they're stumped. What the heck? Why?
April Fools.
It's not April. All right, I do. Excuse me. I do want to know, why are you stumped?
It's just not math. Yeah,
It's not math. Is that what you said?
it's not mathing.
Mathing. What'd you say?
It's not a like math.
Okay.
So we just
Did anybody else check that?
Yeah.
Yeah, so this is not a right triangle. What do we do? Are we stuck?
Yeah, we give up on the spot.
Pack up and wait for the assembly?
Yeah. Exactly.
So since it's not a right triangle, we cannot use trig ratios. And I will tell you, this gets people a lot. Because you look at this, maybe you, like on your test I'm talking about, or maybe just working through problems and you just solved a trig ratio problem and then you get here and you're like, oh, that's for AB, maybe I'll use 53, that's going to be opposite over hypotenuse or something, right? And you're not really focused on what actually needs to be true. And so we can't use trig ratios to solve this, but what's cool is that doesn't mean we're stuck. So now that we know that there's a relationship between angles and side lengths, we can still solve even if it's not a right triangle. And we're going to learn two different, they're called laws, law of sines and law of cosines. They're really just equations that relate angles and side lengths in a triangle. Okay? And the big deal there is knowing when should you use either one, because they don't always apply. But this case, we're going to do law of sines. So let me show you that. So law of sines is always applicable in a triangle. And here's what it looks like. We'll write it down in your notes. But before we do, I just want you to look at it. Like, just what does it say to you? Can anybody interpret this? Don't like read what the equation is, but interpret it in English instead. Okay, good. So, what did you say? Tobin, what did you guys say?
The angles are opposite from the side length.
Okay. Yeah, we do have to make note that what goes in each, these are ratios, right? Each piece is a ratio. What goes in each one is something about the angle and its opposite side. But these are ratios, right? Remember back in similarity, solving proportions? So this is solving proportions with sign involved. Sign is just a number, or at least it can be. So it's not like we're unfamiliar with this. In your notes, I think it's probably safer if you make a new section that clearly stands out from the previous one and now says non-right triangles. Now, these work in any triangle. So I'm not saying you can't use law of sines in a right triangle. I'm just telling you that it's not the best way. For most people, it's not the best way. So for this, we're going to just draw some random triangle. And the big thing here is to make sure you label sides and angles opposite with the same letter. So like A and little a, B and little b, C and little c. Okay, and then our law of sines, obviously sine of the angle over its opposite side. And then same again. Now, have we ever done three proportions at once? Or excuse me, three ratios in a proportion at once? Only two. So same here. You're only ever going to solve two at a time. And honestly, once you get into solving problems, it really comes down to only using two of them, because you can flex the angles and side length names to match whichever you want to solve for. So really the third one is just telling you that it's also true, but not using it to solve. Okay, for this to work, you must know an angle and the side opposite. So in terms of like when do we know when to apply this, that's what tells you. If you know an angle and the side opposite of it, you can use law of sines. Okay, last thing we're going to write, I'm going to put it underneath. And that is works on any triangle. Which means all of this work that we've been doing with trig ratios so far, we could have done with law of sines as well. But it's not necessarily faster to do it that way.